Happy to be here. I'm really looking forward to the Black Lives Matter talk too, so I promise not to go over time. I'm going to give you a little insight into the kind of research I do at Goldsmiths. I do a lot of work with machine learning, but I use machine learning quite differently from how it is supposed to be used. I think I have more fun with it. Just to clear things up, when I say I do machine learning work, or I do work with artificial intelligence, a lot of people think of Terminator. We've already had this discussion today. I don't do this kind of stuff. Not only am I not trying to build superhuman AI that's going to take over the world and kill all of you, I'm actually not trying to make any kind of AI that replicates human abilities. So I'm not trying to make things like AlphaGo. I'm not trying to make self-driving cars. I'm personally just not that interested in making artificial intelligence that replaces people. I'm much more interested in using machine learning with people. Likewise, a lot of people, maybe, who has seen Deep Dream? Okay, some of you. If you are not familiar with Deep Dream, you should go Google Deep Dream. It's a lot of the same kinds of machine learning algorithms that are behind AlphaGo and self-driving cars, except people figured out how to use them to make really weird visual art where you see like dog faces and everything. So you should go look that up. A lot of people think that's what I do. That's also not what I do. I'm not trying to necessarily make computer-generated autonomous art that's like really weird in some way. What I am trying to do is make computer-based tools that support people's existing creative practices and expand people's creative capabilities. So this is my friend Dan. He's a composer and he's a violinist. And you see here, he's got a computer, right? And there's stuff that's going to be very familiar to a lot of you running on this computer. This computer makes his day-to-day job as a composer easier, more efficient. He uses musical notation software, for instance, instead of writing things down by hand, because you can change the music you write a lot more quickly. All right, well, some of the tools I'm going to show you today look a little bit like that software. It's just a matter of saying, okay, how can we enable people to do the things they're already doing, but maybe faster or easier? But then the really exciting stuff comes in when you start looking at the other technology in Dan's environment, like the violin he's holding. Right? We've been using technology in creative practice for millennia, and musical instruments are a really good example of this. Right? Dan is using this violin to do things that he can't do without it. He's making sounds that you can only make when you are using a piece of technology. And unlike the way that Dan uses the computer, he's actually engaging with the violin in a very embodied way. Right? He's not just typing little buttons and moving a mouse around. He's using his ears and his shoulder and his arms and his fingers, and he's engaged in an expert embodied practice. And I'm also really interested in how we can use computers in that way, because that's not usually the kind of interaction that we have. All right, so a lot of the work that I do starts from taking advantage of the fact that we have all these really fun, exciting, affordable sensors that we have at our disposal, and we can start using these to make new kinds of embodied and real-time interactions. So we've got Kinect, you've got sensors in your smartphone. I'm going to do a demo in a little bit with Leap Motion. Lots of you probably use sensors with platforms like Arduino or Raspberry Pi. And this stuff is really fun, right? It allows you to measure how someone is moving, maybe the biosignals coming from a wearable device. It allows you to monitor the environment. And then the question, the really exciting question for me is, okay, what do you do with all of that? So sensing all this stuff, getting data from sensors is increasingly easy, no matter who you are. But then this question of, all right, how do I connect that to controlling something in a useful way, controlling a robot? Or how do I apply that to analyzing my own biosignals to understand something about my health? Or if I want to literally build a new musical instrument, how do I connect that motion that I'm doing to expressive, beautiful, interesting control over sound? And even if you're an expert programmer, this is really hard. If you've ever done any kind of work with sensor data, you end up with just a lot of really boring code. You've got a lot of like thresholds and if-then-else blocks, and it's tedious, and it's really hard to do. So the work that I do largely is about getting rid of this and then seeing what happens. So I'm going to give you a demo in a minute, but I'm going to first of all explain what it is that I do instead of programming. So let's assume that you want to use a sensor like this to build something fun. and you don't want to do programming, if you use machine learning, you can start out by giving examples. You can say, all right, when I do this thing with my hand, that's a closed fist, and that's one gesture, and I want to play one music loop, or I want my game avatar to jump. And when I do some other hand motion, I want some other sound, or I want some other game action. So that's called classification. If you've used machine learning at all, you might be familiar with this. Or I might want to use machine learning to build continuous controls. So I might say, all right, when I move my hand around like this, in this particular way, or when I have a dancer, and my dancer is moving in this particular way over time, maybe I want some virtual controls on my computer to move around in another way and make a particular sound, or change the lighting in a particular way, or change a robot's motion, or something, right? Lots of cool stuff we can do. And machine learning lets us just start from this way of thinking about a problem, which I can explain to you very easily, especially if I'm demonstrating with my body, and we can communicate to the computer in very much the same way. So the type of machine learning I use mostly is supervised learning, and you can think of a supervised learning algorithm as a tool for building models or functions. So if I wanted to build a model that recognizes whether I have an open hand or closed fist, I can send my learning algorithm a bunch of examples and say, this is an open hand, maybe this is another open hand, here's a closed fist, and so on. And if everything goes well, this algorithm will build me a model that then gives me a reasonable answer for new hand positions. All right, so that's it. It's pretty straightforward, and it saves us the job of writing this model function by writing computer code. All right. So the software I'm going to show you is software that I started working on, wrote the first version in 2008. There's a new version as of about a year ago. You can download this, you can play with it yourself. It's called the Buckinator. And it allows you to say, all right, I'm going to make a thing. I'm going to start by showing it examples of motions or things that are happening in the world sensed with sensors. And I'm going to make, just record some examples of this. Give them to a learning algorithm. That algorithm is going to make me a model, a function. I can do new things, and this function is going to classify them or come out with the desired computer behavior based on what it sees. And then if I don't like that, if I want to change that, I can, I'll come back to that. I can actually go back to the training set and give it different examples and say, well, I didn't like what you did when I did this with my hand, so therefore, please do this other thing instead. Right, so it's very similar to a lot of the ways that you interact with another person if you're trying to teach that person something. For those of you who are programmers here and want to know a little bit more about what's happening, I'm sending sensor data to my model, to my software, using a UDP-based protocol called Open Sound Control, which is awesome if you do anything with real-time sensors or sound or animation. You can plug this into game engines, audio software, animation software. So it makes it fun to use. I use it a lot with my students. All right, with that, let's do some demos. I'm going to show you some videos and we'll talk about what it all means. So the first demo I'm going to show you is a really simple computer vision demo. I'm going to run what I call the world's worst computer vision program. It's just going to turn on my webcam and downsample everything to sort of a 10 by 10 pixel matrix. So you can kind of see, there's stuff going on. You can tell that it's me and it's working in real time. But no matter how good a programmer you are, I bet you do not want to be the person whose job it is to say something useful about what these 100 pixels are, actually mean. And a lot of data we have to work with in the real world looks like this, right? It's high dimensional, it's kind of noisy. We can kind of see that there's a relationship between the data and the real world, but it's hard to say what exactly that is. And that's one of the reasons that machine learning is so useful in so many problems. So what I'm going to do is send this data to my software, Buckinator, and we're going to build a little dance-controlled drum machine. And so there's my software, and now let's get our drum machine started. Okay, so there's our drum machine, and what I'm going to do is start out by giving it examples and saying, when I'm standing right here, I want to play this sound. So there, I got 14 little snapshots of me, each paired with that sound. And let's say when I am not standing here, let's play that sound. And now I've built a model from these examples, and hopefully, it's hopefully find a spot around here somewhere where it makes a mistake, right? So I can tell it, no matter how far away I'm standing, this is all still me. Please play that same sound. And it's going to get better from those examples. Maybe it's going to get better. All right, I think I may have given it the wrong information. Let's try it again. So here's me, and here's not me. All right, so I'm basically happy with that. Again, I can keep kind of tuning it if I find things that I don't like. Or I can make it more complicated and say, play that sound when my hand is here. All right. So it's working okay. Still thinks that I'm my hand for some reason. I'll give it more examples and we should be okay. Okay. So there you go, right? That's machine learning in a nutshell. It's pretty easy to use. I've used this with 8-year-old children and they get it. I think I'm a pretty good programmer, but I could not build this app this quickly without machine learning. That's pretty fun, right? If I wanted to use this in performance, I could actually just save this, rerun it, and have my little dance controller. Or I could rebuild it probably if I go to a stage that's not lit like this, or if I'm wearing a different shirt. So it's pretty easy to customize. All right, so that's my first demo, and that's using a classifier, right? It's figuring out, is my hand doing thing 1, thing 2, or thing 3, or my hand plus me, right? So now I'm going to show you something a little bit more fun. We're going to use this Leap Motion controller, which is a nicer sensor to work with. And if you haven't seen this before, it gives you information about what your hand is doing. If you plug it in before you run the software, it'll do that for you. Let's try this. There we go. So there's my hand. It's not a perfect sensor, but it's pretty good. And one of the things that is really fun is just to say, all right, I want to build a hand controller for music. I'm going to pretend I'm like a really lame DJ here for a little bit. So I'm going to run another piece of software. And this software is going to allow me to manipulate a recorded sample. So here's what the music sounds like. All right, so that's the music, and we're going to change pitch and speed of this music, and hopefully turn it into something that I can play expressively with my hand instead of using my mouse and moving sliders around. So let's make a new project, and now I'm going to use the X, Y, and Z coordinates of each fingertip, and I'm going to use those to control those 3 sliders. So let's bring the sound back up, and put this at a reasonable, it's a little bit high, and a little bit fast. Okay. Okay, so I'm going to say, here's the sound I want when my hand is right here. I'll show you. Here's my hand. Right, it's kind of hanging up right there. And let's say I want the pitch to go up as my hand goes up. I can give it some more examples. And there's a higher pitch. And I'll build a model from those examples. And now I've got pitch control. Right? And I can start doing interesting things like saying, well, what if I want to speed up like really fast when my hand turns to the side? I don't know, maybe I want to do that. I'll give some examples of that, and now I'm speeding up very slowly, and now I can go back to a normal tempo. I also get really weird kind of combinations of sounds that I didn't hear initially, which is fun. And I can find ones that I like and play with them. Right? So that's another way of using it. I could just do this for the next 10 minutes, but some videos of things that other people have actually done who've spent more than 10 minutes and who've built some really cool stuff. So I would say the primary users of this software in the last 7 years or so have been composers, people who are doing experimental computer music, people who are actually building new kinds of musical instruments that use sensors and take the information from those sensors and decide what sounds to make. So I'm going to show you a video of a really different musical instrument in a piece made by a friend of mine named Anne Heggie. And here you see each performer is actually pulling strings out of this box, and the position of the strings is changing music. So you can watch the full thing on Vimeo. I really like this piece because, number one, it doesn't sound like what you think computer music sounds like. It's very gentle, it's very warm. And in this piece, Anne really wanted to be able to have the performers do something, it's almost like a yoga sun salutation. She had a particular way that she wanted people to move and had this imagination of sound that went along with that. And so she was able to build that using the software that I just demoed you. This is another one of my favorite instruments that people have built with Wacanator. I'm not going to show you a video of this, but this is a cool instrument. You can look online. I've also used this outside of work with professional composers. One of my current projects is using this kind of approach with similar kinds of sensors to build instruments for kids with different kinds of disabilities. So I'm working with music therapists right now, building totally customized instruments for kids who just physically cannot play acoustic instruments. I've done a lot of work with this software in my teaching, and I teach a lot of workshops on it, and it's always really fun to be able to teach kids or even university students about interaction design, allowing them to just make something cool and new without having to be an expert programmer first, without having to really become expert in doing this sort of signal conditioning from the sensors that they're using. So I've got a couple of videos of some really fun projects that students of mine have done. Let me see if this will play. All right, so this, I'm going to turn the sound off on this. This guy was in one of my summer workshops, and he built a classifier to figure out what facial expression he was making, and then matched each expression to a different internet meme. So I'm going to fast forward a little bit here, and you can see him trying it out. So that one's fun. That's also up on Vimeo. This one is from a workshop I taught about a week ago. Oh, nope, not that one yet. Come on, you can play? There. So this is a student who just hacked together a waving robot using a single motor and Arduino, and it uses this leap sensor to figure out whether someone's waving. And when you wave to the robot, it waves back, which I thought was really cute. And then this one, I will turn the sound back up for this. This is one of my undergrad students wanted to make a self-charming snake system. So the webcam is pointing at the snake. As the snake moves, the motion of the snake gets translated into sound, which then makes the snake move, and so on. He says his snake really likes this. I don't know how you tell. I'm more concerned about the fact that he had a python living in his dorm room at university. Anyway, so these are the kinds of projects that I like doing with my students. And over the last 7 years or so, I've done a lot of serious research on this, trying to understand what is machine learning really good for in these contexts. Likewise, when people are engaged in creative work, what is it that they need, and how can we build computer systems that better meet those needs. And so I'm going to highlight just a few last things before I turn it over for questions. One of the most exciting outcomes that came up early on in this work is that turns out machine learning, you can look at it as a really great way to support the creative process. This isn't what these algorithms were made to do. So the same kinds of algorithms that your bank runs, for instance, when they're trying to figure out whether your credit card transactions are fraudulent. But we're doing something really fun with them here. And you can, I guess, look at this process that I was just doing for you in the demos and note how quickly I can make a new thing. I can make a new interaction in 10 seconds, 30 seconds. And in creative work, that doesn't necessarily mean that people work more efficiently. They don't spend less time creating things. What we often see is that instead people spend a lot of time creating things, but in that time they explore lots of different ideas. And if you look at work, writing about design and engineering and creative work in any field, whether it's building instruments or building bridges or creating architecture, this process of creating lots of different prototypes of an idea, refining those prototypes, exploring lots of different ideas, this is really central to creative work in any domain. And here, machine learning gives you some really nice benefits over coding just by making it fast to experiment. Another thing that I'm really excited about, as I mentioned, is this idea of supporting work with computers that isn't just us typing buttons and moving a mouse around, but actually engaging with computers using our bodies, because we have all sorts of embodied expertise that we bring with us from our real-world experience, being human, or knowing how to play existing instruments, or knowing how to dance, or doing all these other things. And most computer systems don't allow you to take advantage of that. But if you're building something with sensors and you're able to demonstrate how you want to move or how you want to move as the computer does something else, this gives you a pretty nice way of doing that. And again, if you're talking about composers, a lot of the composers talk about, well, this allows me to engage with the computer in a way that's more natural to me. I think about gesture, I think about sound. I don't care about what the mathematical equation is at the end of the day. And the last point I'm going to make is that not everybody who makes things with computers knows what they want initially. And I think this is true even if you're not doing a creative application. You do need to often engage in this process of prototyping different versions of something, trying them out until you find out what you really want. And occasionally, you can make something that is better than what you expected. This is really hard to do with coding, by the way. Usually when you surprise yourself when you're writing code, it means that you get like a compilation error. But with machine learning, often you get something that might be totally new. And you saw that when I was building this hand-controlled instrument, we were getting sounds that we hadn't heard before. And so I think also there's this different kind of relationship that you could say is a very gendered relationship. The way people talk about relationships with computers, the sort of canonical understanding of relationships with computers is often one of control and domination, and I'm going to tell it to do this thing, and I'm going to be its master. And that's probably okay if you're writing a Word document and you don't want it to like start making up words for you. But there are all sorts of other things where maybe you don't want to be totally in control, and you're open to inspiration from things that the computer might do that you weren't expecting. And so Letitia Tsunami, the woman who made this beautiful wheeled instrument, talks about this quite a bit in her work. So anyway, and of course, this is exciting to me because you can engage in all of this without being a programmer. I really like teaching workshops for kids, getting kids building things. And I hope we're moving toward a place where more and more knowing how to program is not a prerequisite for actually making your own things with computers. I love programming, I love teaching programming, but I think there are other ways to be creative and actually to have a lot of agency over things that are made. So yeah, that's the kind of work that I do. If you're interested in learning more about it, I'm teaching a MOOC, an online class. You can find this from my webpage. It's free to sign up and watch the videos. And yeah, if you're interested in this stuff also, I'm always looking for collaborators, looking for students. There's a lot of really fun stuff happening at Goldsmiths right now as well. Okay, thank you very much.
Yeah, why not? A question. Any questions? Here we go. Rebecca, that was amazing. Thank you so much.
So you've alluded to this a few times, and I just wondered if you could give maybe a little bit more detail about it, if that's cool. What do you feel about companies like JukeDeck that are getting so much press and they're winning awards left, right, and centre? So what do you feel about that? But secondly, related, why do you think it's the companies like JukeDeck that get more press when things like this are also happening, which are, like, to me, more exciting?
Yeah, I mean, I think I have mixed feelings about companies like JukeDeck. For those of you who don't know JukeDeck, you can go online and basically say, I want to have an algorithm create a new musical soundtrack for me with these sort of semantic characteristics. And I think that, that is filling an economic gap right now. Lots of people are making, they are creators or being creative in other ways and making YouTube videos, and they want to have a backing track for that. And I don't see anything fundamentally wrong with that. You're not going to go hire a composer to write a backing track to your 3-minute YouTube video. And I do get excited about these tools that encourage more people to engage with creation of content, even if it's not, if they're writing every note. At the same time, I do worry about the economic models that we have to support artists or, not support artists, and that's a big conversation. As for why those companies are getting a lot of attention and stuff like this isn't, I think for one, it's a catchy story to say, oh, we're going to make computer algorithms that steal people's jobs, right? Nobody really wants that, except that it is happening, and it's going to continue to happen. It is, I think, a problem. But also, I don't know, this is academic-y, researchy stuff. I don't have a PR team as much as I would like one sometimes. I am working with companies who are using this in their work, and so one of my projects at Goldsmiths is working with startups around Europe, including Rolly, who's a really cool music startup in London, to put some of this capability into some of the software that they're releasing. So hopefully we'll see some of that coming out soon.
Any other final questions? Everyone's just stunned. They're like, whoa, that was awesome. Play more music. Another one.
What is the gender? I've got lab. What's the gender ratio in your classes at Goldsmith?
It depends. Yeah, gender ratio in my classes at Goldsmiths, we have a really diverse set of programs. We have traditional computer science, and then we have creative computing, music computing, digital arts computing. Those sort of creative technology kinds of programs tend to have better gender parity than the traditional computer science. On the whole, I think we're actually doing pretty well. We're not at 50-50, but we're doing a lot better than certainly any other computer science department I've been a part of. We are trying to continue to do better, and certainly one of the things I do enjoy about being at Goldsmiths is that we have a very diverse student body in terms of not just gender, but racial and ethnic background, class background, and also just the sorts of things that people are into, like the kinds of ideas that people want to do with technology. And I think that's really important. So yeah, I think there's room for improvement, but we're getting there.
Awesome. Well, thank you so much.